Welcome friends, in this video we will discuss some more numericals related to the first law of thermodynamics. So the first problem is a piston and a cylinder arrangement contains a fluid system which passes through a complete cycle of 4 processes. So during such a cycle, the sum of all the heat transfers is minus 170 kilojoule. So if I consider this as the cycle consisting of 4 processes, when the system completes one cycle, the sum of all the heat transfer becomes minus 170 kilojoule. Then in the question they are saying that the system completes 100 cycles per minute. So the system will complete 100 such cycle in 1 minute. Now we have to complete the following table showing the method for each item, and we have to compute the net rate of work output in kilowatt. So this is the table we have to find out one by one. So first what we need to do is we need to find out the del U in the process AB. So along the process AB, by applying the first law of thermodynamics, we can write Q is equal to del U plus W. We have already seen this relation earlier. So now directly I have to fit the values from the table. So just see the table. The value of Q is given as 0, work done is 2170, and del U we have to find it out. So it will come around minus 2170 kilojoule. So the first part is over. In the in the next part, process B to C. For the process B to C also we have to find out del U, the value of del U. So same, just apply the first law of thermodynamics. Q is equal to del U plus W. Then the value of Q is 21,000. From the table I can see it, and work done is 0. So I will get the del U value to be 21,000 kilojoule. So the first two is over. In the next step, we need to find out work done. Now Q and del U is given. So along the process CD, we have to apply the first law. So by after applying the first law, directly we will fit the values whatever given in the table. So from here, the value of W can be found out. The work done can be found out as 34,500 kilojoule. So the first three steps are over, process AB, BC and CD. Now we have to find out for the process DA, we have to find out all these three terms, Q, W and del U. So this is somewhat tricky. Okay. So along the process DA, first let us try to find out Q. So I have one clue in the question. It is they have said that summation of all the heat transfer during a cycle is minus 170 kilojoule. This is given in the question. And also given in the question is one more thing, that the system completes 100 cycles per minute. So the net summation of heat transfer will be minus 170 into 100. So it will be minus 17,000 kilojoule. This is the net heat transfer during the entire cycle. Okay. Now again, the net summation of net heat transfer is nothing but the heat transfer in the individual process. The cycle is comprising of 4 processes, AB, BC, CD and DA. So if I add all these heat transfer, I will get the net heat transfer. So I can write QAB plus QBC plus QCA plus QDA is equal to summation of QNet, right? So just now I have to just plug in the values. So minus 17,000 is equal to QAB is 0. It is given QBC, QCD, all these things we have found out, and only unknown is QDA. So QDA can be easily found out. We can easily find it out, which is coming around minus 35,900 kilojoule. So the first part is over. Now we have to find out work done. Okay, now for a cyclic process, we know that del U is 0. Why del U is 0? Because Del U is nothing but the difference between final internal energy value minus initial internal energy value. But for a cyclic process, the system is coming back to the initial point. So initial U final and U initial are same, so it will be 0 always. And we can also write del U for the entire cycle can be written as del U for the process AB plus del U for the process BC plus del U CD and plus del U DA. So this can be, this will also be equal to 0 because it is completing one full cycle. Now individually we can substitute the values of del U, AB, BC, CD. Okay, only DA will be unknown and we have to find out the value of del U DA. So it is coming around 17770 kilojoule. So two things we have found out, QDA and QDA and del U DA. Now the last thing is left, work done during this process. So if I write the first law of thermodynamics here, so directly I will get the work done during this process. Okay, so this was the first problem. All these three things I have found out. Okay, next, in the next problem, a gas undergoes a thermodynamic cycle consisting of three processes beginning at initial state where P1 is equal to 1 bar, V1 is equal to 1.5 meter cube, U1 is equal to 512 kilojoule. So let me first draw the draw this process. So if I draw the PV diagram, in between the two states 1 and 2, I will have my process like this. Next, from 2 to 3, the it is a constant volume process, so work done is 0. From the question I can see that the work done is 0 and Q23 is minus 150 kilojoule. Then after this point, the system again goes back to the state 1. So it is completing one cycle, one big cycle, one round cycle. Now I have to find out Q12 and Q31, that is heat transfer during the process 12 and heat transfer during the process 31. So all this in the right hand side I have shown all these processes, process 1, 2, 2, 3, 3, 1. You can refer this figure. If you have any doubt, you can ask in the comment section. Okay, so now moving forward, we have to find out Q12. So applying the first law of thermodynamics, I can write Q12 is equal to del U12 plus W12 for the process 1 to 2. Okay, so let it be equation number 1. Now work done during this process will be, it is an isentropic compression process. So work done during such a process is given by P1 V1 ln P1 by P2. We have already derived this equation, this relation in one of the previous videos. So in this video we have to just plug in the values. So P1, V1 and P2, these are given in the equation. So just put the values and the work done will come as minus 103.97 kilojoule. Fine. So next is we have to find out del U1 to 2. So del U1 to 2 is nothing but U2 minus U1, and if you see in the top left portion in the given section, U2 and U1 values are already given. So directly put these values and 690 minus 512 and you will get the answer as 178 kilojoule. Now we have found out work done and del U for this process. So we will just fit these values in the equation 1 and we will get the value of heat transfer during the process 1 to 2. So 178 minus 103.97, it will come around 74.03 kilojoule. Okay, so the first part is over. Now only one thing is left. We have to find out in the second part, they are asking find out the value of Q31 during the process Q31. So again, writing the first law of thermodynamics for this process, Q31 can be written as del U31 plus W31. Okay, now let it be equation number 2. Now in the question W31 is given, it is 50 kilojoule. Okay, it is already given, but del U31 we do not know. So del U31 can be written as U1 minus U3. Now the problem is that we do not know the value of U3. U1 we know, but we do not know the value of U3. So we can write del U31 is equal to 512 minus U3. Let it be equation number 3. So we have to find out the value of U3 from the previous, from one some other process. So let us take help of the process 2 to 3. So along the process 2 to 3, Q23 can be written as the del U23 plus W23 from the first law of thermodynamics. Q23 is given as minus 150 and work done is 0 since it is a constant volume process. So del U23 is minus 150. I can see here. Again del U223 can be written as del U3 minus U2. So U3 can be written as U2 minus 150. U2 is already given in the question, 690. So 690 minus 150, it will come around 540 kilojoule. So I have got the value of U3. Now what I will do is I will put this value in the equation number 3. So let me do this. Putting this in the equation number 3, I get del U31 can be written as 512 minus 540, which is coming around minus 28 kilojoule. So now del U31 can be put back in the equation 2. I'll just go back. This is the equation number 2. So if I plug in this value here, what I'll get is Q31 is equal to minus 28 plus 50, which is equal to 22 kilojoule. So this is the answer. Q12 we have got already 74.03 kilojoule and Q31 is 22 kilojoule. So this was all about the numericals from the first law of thermodynamics. In case of any doubt, you can ask in the comment section. And for more such videos, please subscribe Megvidya.